Alright, this is a video for Lab 6, which is also the first lab for the fan part. Okay, so first you want to go to web course. In this folder. You need to download this zip and unzip this file into one folder. Okay, that's what I did here. So you would need to unzip all the files out of the compressed file. Okay, then so basically, if you open this assembly, this is the top assembly. Let's open this. Basically, this is a CAD model for our project. It's a little bit modified from what we did. So now it's loading up. Okay, I'm going to adjust this to proper width. So here is the model. We deleted some edge blend and make it less roundy, so it will be easier for the meshing. Okay, anyway, so for the first lab, we're going to first start the Fem and the Sim from this assembly model. Then we will modify the idealized parts, which we will introduce later. And after we modified the idealized part, we will mesh this wheel, 3D mesh. Alright, so let's start. So first thing is in this assembly, okay, you want to start a advanced simulation. Let's move this to a better location. Okay, so you want to click Start and Advanced Simulation. Now you're in advanced simulation, as you can tell from the top. Okay, but we don't have sim and fem files right now. So you want to build a new sim and simulation and fem. So you need to right click this assembly file here in the navigator and choose new fem and the simulation. So here just make sure the this option is checked, create idealized part. Okay, and usually it's the default option, so usually you just have to click OK. Then it will create a simulation. Then it will ask you for what kind of solution you want. Do you want to do linear static, which is what we're going to do, so you just click OK again. Alright, the steps are detailed in the slides also. So now we're in the sim, right? .sim here, and if you go to Window, you can see we have four files open. The bottom one is your assembly. Then usually we have the sim and fem, and let's go to the fem. Take a look. Now we don't have any mesh here. We have some polygons. Now we have 10 polygon now. Okay. However, as Dr. Zarda said in the class, this is a symmetric geometry. It's symmetric on a lot of ways. So for the wheel and the wheelbase and this bearing, it's only symmetric on the YZ plane. Okay, we can tell from here. And for the body, it's actually has 6 symmetry plane, or if you can say that's 3. Okay, so we can actually cut this into 1/6 and then only mesh that part, so it will be much easier. Alright, now we have 10 polygons, and we need to modify or we need to split the body in the idealized part. So idealized part is this file, So whatever in front slash I.prt. So there's a warning, and click OK. So idealized part is let's say in terms of the relationship between those files. Okay, so idealized part is based on your master model, which is the assembly. The fan is based on your idealized part instead of the master model. Why is this? So sometimes your model is complicated, or your model has very detailed geometries. And sometimes like this, in our case, it's symmetric, and you only need a half of the model, but you don't want to mess up with your master model because that's for manufacturing. Or so you can modify your model, your CAD model, in idealized part without tempering your master CAD. So that's explained here, and also the dependency relationship. Okay. So in this idealized part, if you want to do any modification on a single part, you cannot pick it because it's kind of a whole. NX will consider this as a whole geometry, like a whole piece solid. So you can't really, let's say, split body. You cannot pick anything. So the first step is to promote, to extract this part to your assembly level. Then you can modify this in the idealized part. So promote is here. Okay, sometimes people get confused with promote body. So if you search promote, okay, we actually want this first one, promote. It says advanced simulation toolbar. You don't want to choose promote body. That's in the modeling application, although they have the same icons. So promote. Okay, now here it says promote body, which is confusing. Just remember, for this idealized part, we need just this command on the toolbar. Okay, and the next step, we need to extract these three parts: the wheel, the wheelbase, and the body. And click OK. Now if you hover your cursor on the wheel, you can see this is the promote body. And if you move your cursor here, it's actually not promoted. So why we only need those three? Because we can just mesh a half of this and reflect or translate to the other corners because they're all the same. Okay. So next step, for the wheel, it's symmetric, right? It's symmetric on half and half. So we can cut it into two pieces. Now you need to find the split body command, and select the body. We can select this wheel first. Then for the tool, which is a cutting plane, you want a new plane. Okay. And then here you can choose. We need a plane that's parallel to the XZ plane, but at distance. So here you can pick this XZ plane from here, and I already did this a couple times, so I have this value here. For you, it's gonna be 0 here. So you will need to change this distance, but you don't know it yet. Of course, you can measure that from the model. So we can measure the distance on the fly in this command. You can just click on this arrow and find the measure. This is just like the measure tool here. Okay, so you want projected distance, the distance projected on Y direction. So we can click here, Y. Then the starting point would be the absolute origin. It's okay, probably you can click the point. Okay, sometimes if you don't have this datum here, you have to go into this point dialog. By default, it's the origin, so you can simply click OK. And the end point would be any point on the axis of this wheel, or the axle of the wheel, which is also the center point of this edge. So those points, just pick either one, or center line, that's okay too. Okay, because we're talking about the projected distance on y direction. So that will be the number 3.375. Okay, if you're lazy, you don't want to measure, you can just type in this number, given you're using our model. Alright, now you can click OK. Now this value will be inputted into this distance. Okay, now, and you can examine where the plane is. Okay, F8, it's right in the middle, and you can click OK. Now right away you can tell the wheel has been cut into two pieces, okay, because they have different color. Then next step, we're going to cut the wheelbase and the dolly body. Okay, again we're going to use split body, and this time we'll pick the wheelbase and the dolly body. And now this time the plane would be YZ plane. So the normal will be X, which is on the icon. So that's the plane we're going to use. Take a look. Okay, and click apply. Now you can tell they're cut. Now the last step is, of course we can mesh this half and half for the body, but it's also symmetry on this direction, right? So we can make another cut here and use this. This is 1/6 of the whole body. So you can reflect this to this side and reflect that 120 degrees. So that's what we are going to do. So now this time the cutting plane is not any perpendicular plane to the datums. So we need a new plane which is at angle. Okay, because we're going to cut this way, that will be about 60 degrees to YZ plane. So specify a plane at angle, and here says select a planar object and a linear object. So first we need to find your YZ plane. Although I put a datum here in the assembly, it's hard to pick it up, or it's impossible to pick it up. That was the World Cup. Alright, so the YZ plane, remember we just cut the body using YZ plane. So we have a plane here on the model. If you move your cursor in here, and I'm gonna rotate, right, that's the cross section of your YZ plane to the dolly body. So that will be our planar object. Then the linear object will be a hinge between the angle between two planes. So either this one, the center line, as long as you pick the center line that's in the center. So you can try hovering a mouse on this circular face, I'm sorry, cylindrical face, and then you can pick this center line here. Okay, now that's the hinge if you look from the top. So here you want 60 degrees, or maybe probably that's be 240 or 60, depending on how you pick your plane and the axis. Okay, but you do want this plane to go across the absolute z-axis or the center of this model. Alright, now I haven't picked the body yet, so let's go back to rendered and pick this half, and now we have the body, we have the plane, and you can just click apply. This time it didn't assign a new color for different pieces, but you can tell from here, right? Okay, so that's all the work you have to do in this idealized part. Okay, now let's move to the next step. That will be in the Fem. Okay, so once you switch to the Fem, there's a window saying, okay, you just cut some polygon in the idealized part. Okay, now I'm updating the polygons. Okay, now remember when we first came to the Fem, there were 10 polygons. Now we have 17 because we cut those open, and you have more pieces here. So first thing you want to do is actually find the masked copy we're gonna use for the mesh. So turn them all off, and okay, that's the one I need. Usually the newly generated polygon is at the bottom, because the top is like they're already there. Okay, so let's find the half we will be using. So that will be this is like a unit of the Dolly, right? So with this you can reflect, you can translate, and you can make the whole Dolly. So these three pieces are all the pieces we need for meshing, and it's a good habit to rename those polygons. So I'm gonna rename this as a wheelbase, and that's the wheel, and this is the body. Okay, now we only have 17 polygon here. Sometimes you have like 700. So it's a good idea to rename them, otherwise you will never be able to find them. Okay, so today we are going to mesh the wheel only, so you don't need wheelbase and the body. We just need this polygon on the screen. And okay, for this mesh we will use 3D swept mesh. Swept, it's, if you remember the swept command from CAD, right? You have this cross section, and it's the same to the end. If you sweep this along the circle or the arc, okay, so that will be very regular, instead of if you use Tetris, sometimes it's very irregular mesh. So 3D swept mesh, and you want to choose until target. This is very regular. Sometimes it's okay to use just the first one, but we can be more specific on this. So the source face would be this face, and the target will be the face to the bottom. Okay, that's 180 degrees from the source to the target. Oops, I just picked two. So I'm gonna hold down Shift and click the bottom one, and move down to the target, pick the bottom. Alright, the element type will be hex 8, okay, which is linear, but also this is not texture, so it's okay to use linear hex for the solid. It's not very rigid element. And the element size will be 0.1 inch. Okay, and you can try to use this attempt free map mesh. So let's take a look at the results. Now it looks pretty symmetric, left and right, and also you can tell from here it's like, you know, the pie shape. That means it's swept from this face. Okay, so that looks good. We can just go ahead and click OK. Next step, this is only a half of the wheel, right? We need to make a whole wheel first. So it's the same as a cat. You can have reflect command. However, here the difference is you want to insert some element which is copied and reflected from this half wheel. So we will use copy and reflect for this. And here, in our case, we only have this wheel on the screen. Sometimes if you have a lot mesh on the screen, you want to turn them off. You just need one, the one you are going to reflect. Why? Because see this, it's hard to pick, them by just click once. You have to use a box select. And if you have other meshes on the screen, probably you will pick them up accidentally. So here is the all the mesh we're going to reflect. And if you notice, okay, we will reflect the cross section also. That means after you reflect, in the inside of this wheel, we will have two faces of nodes. Right. So if I reflect this face, you will have two faces at the same place. So that will have some problem. We will talk about that later. Anyway, so let's pick the reflection plane. And here somehow I don't have the inferred plane option here, but you can use at distance. If you have inferred, that will be the best. And for this option to work, you have to have this wheel polygon on, because your mesh doesn't have a face. Okay, you have to pick the polygon face, as you can tell from this cursor. And once you click the polygon face, keep the distance at 0. So that will be our symmetry plane. And you can just click OK. Now you would say, okay, that's a whole wheel, I'm done, right? But like I said before, we also reflected this face of nodes. So after reflection, in the symmetry plane, okay, we have duplicated nodes. It's like it's already cut open and you reflect it. It's not, the cross section is not glued on yet. It's all still cut open. So what's next? First, if we have some kind of mesh like this, you cannot tell if it's one piece or two. There's a way to check it. It's called element edge. Okay, so this element edge tool will display the external edge, or as it's called, the free edge. Okay, so the free edge is your external edge of a solid mesh or solid element. So once you pick those two meshes, you can click Generate Element Outlines. And as you can see, let me turn to a static wireframe. We have external edge inside the solid. That's the I-shaped the cross section. So the circles are good because they're on the outside of the solid, but you don't want any external edge inside your solid. That means you have a cut over there. So what do we do? First, after you turn off that command, the blue lines are still there, so you can right click and refresh. Okay, now next, as I said before, because we reflected the face, so we have duplicated nodes on that face, so we can use this duplicate nodes. Okay, in this command, you will find duplicated nodes within this tolerance. You don't have to change this unless your model is not very regular. Okay, then, but for this case, once you click those two pieces, that's the locations where you have duplicated nodes. That's also the cross section we just reflected. So you have the option to merge those nodes. Once you click that, let's go back to the element edge check. Okay, you can pick those two meshes. There's still two pieces of mesh. However, if you click generate element outline, you don't see any external edge inside your solid elements, which is good. So that's how you merge two pieces of meshes, given they have like duplicated nodes at very close distance. Okay, so that's also in the slides. And the next step would be if I turn half of this off, do you think is it displaying all the elements? This is a solid element, a solid mesh. You should have elements inside, right? But do you notice like there's no lines inside this mesh? So we can display the internal element edges. You can tell from the, you can take a look at the difference. So now it's only the external elements are shown. Okay, now if we enable this and click apply, you can see that's actually the real mesh you're looking at. You can see there's like structure inside the mesh. Why do we need this? I guess the old times when you do a copy and reflect, if you don't show the internal edge, it will not reflect the internal edge. But nowadays they're both there. Even though we didn't show the internal edge, it's still reflected. So that's sometimes you would need to see the internal edges. Okay, and also in the slide I said you can play with this shrink command. Let's try set this to 20 and apply. That's pretty cool looking. And also you can tell from here you don't see anything inside. We made the element face smaller so we can look into the solid element, but there's nothing inside. And if you display the internal element edge, now you can see, actually you can see all the elements because they're shrinked, so you can see the internal elements. So that's also a way to see internal elements. And I guess that's all for today's lab. Alright, thank you.